You can see example 5 written out here. We're to show that the point 2, 4 lies on the graph of x cubed plus y cubed minus 9xy equals 0. Then after that, we need to find the equation of the tangent line to the curve at that point. So how do we verify that a point lies on a graph, lies on a curve? Well, for a point to lie on a curve, it just means the particular x value and y value of that point satisfy the equation. In other words, when we put x of 2 and y of 4 into the equation, then we get a true statement. If we didn't get a true statement, then that point would not lie on the curve. So we're going to take our x value of 2 and replace x with a 2, so we have a 2 cubed. And then we're going to replace our y value with a 4, so we have a plus 4 cubed. Minus 9 times our x value again is 2 times y, and our y value is 4 equals 0. And that's the question. Does it really make this equation true? So we begin just evaluating. 2 cubed, of course, is 8. And 4 cubed, of course, is 64. And 2 times 4 is 8, and 9 times 8 is 72, so we have a minus 72. And so we want to know if this is true. Well, 8 plus 64 is 72. So we have 72 minus 72 equals 0. And of course, we can see that that's true. So yes, we see that we knew that it was going to be the case, but now we've verified that the point 2, 4 actually lies on the curve. Well, you can see that I've sketched in a curve here, and it's obviously not real accurate because I've hand-drawn it, but actually this is called the Folium of Descartes, and that's not really anything that we care about, but it is the graph of x cubed plus y cubed minus 9xy equals 0. And here I've illustrated the point 2, 4 that's on the curve, and so what we're finding is the equation of the line tangent to that curve would be like this. So we're looking for the equation of this line. We'll kind of put it in perspective of what we're doing. But now to find the equation of a line, let's just remember, we need a slope, that is the slope of our tangent line, and we need a point that's on the tangent line. Now, the point is basically given to us, isn't it? 2, 4. It's not only on the curve, but it's also on the tangent line because it's the point of tangency. So the slope is what we're going to have the issue with. And to find the slope, then, what we need to do is to find the derivative. That's how we find slopes. And then we need to use that derivative and evaluate that derivative. And we've seen, in this case, maybe not just at the x value of 2, but at the point 2, 4, because we may have a y value in the derivative as well. So that's what we've got to do for our work, and then we'll put those together and get the equation of the line. So this is what we're after right now. Okay. Well, let's take the derivative of both sides. And so when we take the derivative of the left side, we'll have the derivative with respect to x of x cubed plus the derivative with respect to x of y cubed minus the derivative with respect to x of 9xy equal the derivative of 0, of course, with respect to x. Now, here's what we're going to do. The derivative of x cubed with respect to x is certainly just 3x squared, isn't it? So that's not a big deal. The derivative of y cubed with respect to x is the general power rule, the chain rule, isn't it? It will bring down the 3, reduce the power by 1, but then we have to multiply with what's on the inside of the parentheses, and that's what we're calling derivative of y with respect to x. Minus, let me just hold off on this derivative of 9xy for a moment. An equal derivative of 0, of course, is 0, because it's a constant. Now, what I want to do here again is I want to take this derivative, and we've got to use the product rule on it. See, that's really what I'm wanting to do, is it's okay. Use the product rule to find the derivative of 9xy with respect to x. And we have to do something a little different here. I'm going to think of the first function as being 9x and the second function being y. So it's first function times derivative of second. And in this case, the second function is y. And then it's plus second function times derivative of first function. In this case, the first function is 9x. Well, the derivative of y, we have this 9x. Well, you can hear I forgot to turn my phone off. Okay, I'm taking care of that. But we're back at 9x, or I'm back at 9x times the derivative of y with respect to x, and we'll just call that derivative y dy over dx, plus y, and the derivative of 9x with respect to x is just a normal derivative, that's just 9. And so I'm going to just rewrite this a little bit. I have 9x times dy over dx plus 9y. Now, that's what we did. That's this derivative, isn't it? So using this product rule, we're going to come down here and then replace all that mess, or replace that derivative of 9xy with all of this mess. So we've got our original 3x squared plus 3y squared times the derivative of y with respect to x. And then we have this minus sign, don't we? And we're subtracting the derivative of 9xy, which is 9x derivative of y with respect to x plus 9y. And I've got that in brackets or parentheses because that minus sign in front of the original derivative is going to affect everything inside, isn't it? Okay, well, let's go to the next page here and see where that puts us. We'll need to distribute that negative sign, and so now we have 3x squared plus 3y squared dy over dx minus 9x dy over dx minus 9y equal 0. Now, what is it we're trying to find? See, we need to understand where we are, and it's easy to lose track. Now we need to solve for dy over dx, don't we? We need to find the slope, and to find the slope, we need the derivative of y with respect to x. And so we look at this equation, and we say, okay, we've got two terms that involve dy over dx and two terms that do not. So let's gather the terms involving dy over dx to one side and the things that don't involve it to the other side. So that means I need to get rid of the 3x squared I've got here, and I need to get rid of the minus 9y I've got here. So I'm going to add 9y and subtract 3x squared from both sides. And so on the left side, I'll be left with 3y squared dy dx minus 9x dy dx. Those involve what I'm solving for. The others don't. So when I add 9y to the right side, I get plus 9y, and when I subtract 3x squared from the right side, I get minus 3x squared. Of course, they disappear from the left side. Now, we have the two terms on the left side, both have this common factor, dy over dx, and so I'm going to factor it out. So I have 3y squared minus 9x times derivative of y with respect to x factored out, equal 9y minus 3x squared. Now, to solve for dy over dx, I need to divide out that coefficient. So I'm going to divide on the left side and the right side by a 3y squared minus 9x. After all, that's what I'm trying to do, is get the dy over dx by itself. So these are going to cancel there, aren't they? On this side, though, whoops, I say 9y y minus 3x squared divided by a 3y squared minus 9x. Okay, so I have derivative of y with respect to x is equal to 9y minus 3x squared divided by 3y squared minus 9x. And I don't know about you, but I'm recognizing that there's a common factor of 3 in the numerator and denominator. So I can factor out a 3 from the numerator and get 3 times 3y minus x squared, and factor out a 3 from the denominator and get 3 times y squared minus 3x. And then those 3's will cancel, and I'll end up with just 3y minus x squared over y squared minus 3x. Okay. Now, where am I? Let's remember, we've got the point that we need. We're coming up with the equation of the tangent line. And the point that we are going to use is 2, 4. The slope we still have to calculate, but we're close now. The slope we calculate by taking the derivative and evaluating it at the point 2, 4, the point of tangency. And so that means, of course, we put a 2 in for every x and a 4 in for every y. So when we look over here at this derivative, then I have a 3 times my y value, which is 4, minus x squared, well, x is 2, divided by my y squared, well, y is 4, so 4 squared, minus 3 times my x value of 2. And what is that? 12 minus 4 over 16 minus 6, which is 8 over 10, which reduces to 4/5, doesn't it? There's the slope I need. Okay. So now for the equation of the tangent line, that's a good review, isn't it? What do? We use this y minus y sub 1 is equal to m times the quantity x minus x sub 1, where m is the slope, and x sub 1, comma y sub 1 is the point that we're using that we know is on the line. So this becomes y minus our y value 4 is equal to our slope, 4/5 times x minus our x value of 2. And then we'll just begin to simplify this. Y minus 4 on the left, 4/5 x minus 8/5 on the right. Add 4 to both sides. And now we need a common denominator, don't we? So we can combine the minus 8/5 plus the 4. Well, 4 is 20 over 5, and so that ends up being what? 12/5. So we end up with, let's come up here, so we end up with y is equal to 4/5 x plus 12/5. There's the equation of said tangent line, which is certainly feasible from the graph the sketch of the graph that we saw earlier. Well, this is the last of my examples for implicit differentiation. I hope it's helpful. Good luck on your work.